Good morning. I'm going to discuss one of the very important topic in the electrical engineering is the power factor. Before going in the depth about the power factor, I want to tell some of the basic idea about the power factor. The power factor is a measure of how effectively electrical power is being used by a system. It is defined as the ratio of the real power, the power actually used to perform the work, that is measured in the watts, to the apparent power, the total power supply to the circuit measured in the volt ampere. So mathematically the power factor can be written as the real power divided by the, this is real power divided by the reactive power. So real power can be noted as the in the P, and this is S. So real power factor is equal to P by S. So measurement of the power factor is kVA, the SI unit, and the real for the real power, this is the kilowatt, and the for the reactive power, it is the kVAR. Reactive power is nothing but the wasted electricity, and the real power is the usable electricity. So real power P is the actual power consumed by the equipment to perform useful work like running motors, lighting, and heating. Whereas the apparent power. So, what is apparent power? Apparent power is denoted in S, is the combination of the real power and the reactive power which does not perform any useful work but necessary to maintain the voltage level needed for the equipment to function. Reactive power arises due to the presence of the inductance and the capacitance in the circuit. The power factor is a dimensionless number between the 0 and 1, often expressed as a percentage. The power factor of 1 or the 100 percentage indicates that all the power is being effectively converted into the useful work. Lower power factor indicates a higher proportion of power is being wasted in the form of the reactive power. There are two common causes of the low power factor: inductive load. Many electrical devices, such as a motor and transformers, are inductive in nature. These devices create a phase difference between voltage and the current, leading to the generation of the reactive power. This phase difference causes the power factor to be less than 1. Capacitive load. Capacitive load such as the capacitor bank or the some type of the electronic equipment can also cause the phase difference. But typically they are used to counteract the effect of the inductive loads and improve the power factor. The power factor can be represented in the different forms: lagging power factor and the leading power factor. Lagging power factor indicates that the current lags behind the voltage common in the in inductive load. Leading power factor indicates the current leads the voltage common in the capacitive load. Next, installing the improving the power factor is often desirable because it can cause the efficiency of the power system. This can be achieved by the adding capacitor, using synchronous condenser, installing the power factor correction equipment. So adding capacitors can counteract the effects of the inductive load, thus improving the power factor. Using synchronous condenser, these are specialized synchronous motor that can adjust the power factor by varying their excitation, installing power factor correction equipment, devices that automatically adjust the power factor to an optimal level. A high power factor, a reduced power losses in the electrical system, lower electricity bill, and less strain on the electrical infrastructure. Consequently, many power companies charge industrial and the commercial customer a penalty if the power factor falls below a certain level, encouraging them to implement the power factor correction measures.